Welcome back, students. This is the session 4 from the playlist of IIT JEE Physics Mains Part 1. The topic for this session is the calculation of zero error in the Vernier Caliper, and the question is written on this board. So similar type of questions has been asked in the previous JEE mains examinations, and here the question is, the 10 main scale divisions of a vernier caliper is equal to 1 centimeter. The 10th vernier scale division matches with the 9th main scale division. When the jaws of the caliper touch each other, the zero of the vernier scale is to the right side of the zero of the main scale, and the 6th vernier division coincides with the main scale division. The main scale reading of the length measured is 4.3 centimeter, and the second vernier division coincides with the main scale division. So we have to find the true length. So now first thing is that in order to solve this question, you all have to understand about the zero error. So here I have made one simple diagram here. This is the vernier caliper, this is the main scale of the vernier caliper, and this is the vernier scale. This is the vernier scale, and this is the main scale of the vernier caliper. Now, when the jaws of this vernier caliper, they touch each other, and in that case, if the zero of the main scale is not coinciding with the zero of the vernier scale, then we say that there is a zero error in the instrument. Now, if the zero of the vernier scale is on the right side, as it is shown here, this is the zero of the vernier scale. If it is on the right side of the zero of the main scale, then we say that this is a positive zero error, and in that case negative zero correction is applied. So in this case, when the jaws of the caliper touch each other, the zero of the vernier scale is on the right side of the zero of the main scale. So this is the zero of the vernier scale, and it is on the right side of the zero of the main scale. So this is a positive zero error, and here negative zero correction will be applied. Now zero correction will be negative, and zero correction is basically equal to the least count of the instrument into the coinciding vernier scale reading. Now here we have to find the true length of the object which we are measuring with the help of this vernier caliper. So here now the true length will be equal to the measured value, which here I am writing as MV plus minus zero correction. Now when the zero error is positive, then negative zero correction will be applied. So in this case, the zero correction will be negative, so the true length of the object will be equal to the measured value minus zero correction. Now zero correction is what? Zero correction is equal to the least count into the coinciding vernier scale reading. So here you can see here that when the jaws of the caliper touch each other, then the 6th vernier division coincides with the main scale division. So here in this case, it will be equal to 6 times into the least count of the vernier caliper. So here we have to find the most important thing is that we have to find the least count, and we also have to find the measured value. Now the measured value is equal to the main scale reading plus least count into the coinciding vernier scale reading, and in this case this is the measured value, and the true value will be equal to what? This will be equal to main scale reading plus the least count into the coinciding vernier scale reading minus zero correction. So we have to find the measured value and we have to find the zero correction. So here the main scale reading of the length measured is 4.3 centimeter. So we are given this, that is the main scale reading is equal to 4.3 centimeter. The first thing is there. Now we have to first of all find the least count. Now the least count of the vernier caliper is equal to 1 main scale division minus 1 vernier scale division. Now here 10 main scale divisions of the vernier caliper is equal to 1 centimeter. That is 10 main scale division is equal to 1 centimeter. So it implies that 1 main scale division will be equal to 1 by 10 centimeter, or this is equal to 0.1 centimeter. Okay, so the value of this main scale division, I will be just writing it here. That is 1 main scale division is equal to 0.1 centimeter. Now, second point is here, we have been given here is that the 10th vernier scale division is equal to, is coinciding with the 9th main scale division. So 10th vernier scale division is coinciding with the 9th main scale division. So 1 vernier scale division will be equal to 9 by 10 main scale division. And this is now 1 main scale division is equal to 0.1 centimeter. So this will be equal to 0.9 upon 10 centimeter, or this will be equal to 0.09 centimeter. So 1 vernier scale division is equal to 0.09 centimeter. Now least count of the instrument is equal to 1 main scale division minus 1 vernier scale division. So 1 main scale division is equal to 0.1 centimeter and 1 vernier scale division is equal to 0.9 centimeter. So this is equal to how much? 0.10, 0.09, 1. This is equal to 0.01 centimeter. So the least count of this vernier caliper is equal to 0.01 centimeter. So I am writing it here now. Least count is equal to 0.01 centimeter. Now, here we have to find the value of this zero correction. Now, since this is a positive zero error, and so therefore negative zero correction will be applied. So this zero correction will be equal to, see here, the this will be equal to 6 times 6 into the least count of the instrument, which is equal to 0.01 centimeter. So this is equal to 0.06 centimeter. So we have found the value of zero correction. Now we have to find the measured value. The measured value is equal to main scale reading, which is equal to 4.3 centimeter, plus least count into the coinciding vernier scale division. So here you can see here the main scale reading of the length measured is 4.3 centimeter, and second vernier division is coinciding with the main scale division. So here the coinciding vernier scale reading will be 2 into the least count. Least count is equal to 0.01 centimeter, and since the zero error is positive, so we have to apply this negative zero correction. So the value of the this zero correction is 0.06 centimeter. So here this value will be okay, now this is the measured value. So measured value is equal to so this value is equal to 4.3 centimeter plus 0.02 centimeter. So this is equal to 4.32 centimeter. So this is the measured value. Now we have to find the true value. So the true value, or you can say the true length, is equal to the measured value, that is 4.32 centimeter, minus zero correction. Now what is zero correction? Zero correction is equal to 0.06 centimeter. So this is equal to 4.32 minus 0.06. This is equal to 4.26 centimeter. So the true length is equal to 4.26 centimeter. So in this question, the most important thing which we have to remember is that when the zero error is this zero error is positive, when the zero of the vernier scale is on the right side of the zero, the main scale, when the jaws of the vernier caliper are in contact with each other, and when the zero error is positive, the zero correction when the zero error is positive, then we have to apply the negative zero correction. That is, the true length will be equal to the measured value minus zero correction. That is, we have to subtract the value of zero correction from the measured value in order to get the true length in case of the positive zero error. So thank you very much for joining this session. In the next session, I will be continuing with the topic of zero error, but it will be I will be taking up the question in which we will be finding the zero error in the case of screw gauge. So thank you very much again. Until then, have a nice day. Bye.